Greetings all, hope this finds you well as always. It's now time for a latest update from the machine shop, of which there isn't actually much, I'm ashamed to say. This week I've mostly been over in Cumbria mucking around with other things, and so I've only just got back, only back in today actually. Brian's been in today. He's continued on with these bolts we've seen before. He's continued doing a lovely job as always. And he's finished off the longer, larger shanked bolts. These are to go into 806's buffer booms, I've said before, and there's different lengths. If you look at those, you'll see they're subtly different lengths. That is entirely deliberate because there's actually subtly different lengths of plate they need to go through. And so Brian's made them all custom made to individual holes. He's got all the long ones done, and there's 4 done there. He's got the rest lined. The rest of the blanks lined up in front of them there. He's hoping to get them finished tomorrow, and then that's that job done, dusted, finished. I've had a few other bits and pieces of repair jobs in. We've had a drain cut valve off the 9F that young Andrew's been overhauling, and he discovered that the seat in the body was quite badly cut. He needed to sort it out. The only minor problem was we didn't have a seat cutter capable of doing it, and I don't actually really like seat cutters anyway. So to get the job done, and I haven't got any video or footage of it, unfortunately, because it had to be out. But we managed to set the body up in the forger on the big Mostana, and then cut it. 806's header, I'm in the process of sorting that out, because as I said, we discovered it's moving slightly while being cut. So I'm in the process of inserting an angle plate at the back of it so the little swine can't escape. And I've got it to realign, so that'll be tomorrow's fun and games. And then, to be honest, that's really about it that's gone on this week that I've been aware of. So anyway, something I thought I might just talk about then for a bit is we've had how I go about designing a component. We've had how I go about planning a repair, which still hasn't happened. That's next week's excitement. And so I thought I might just say a few bits about measurement and how we actually use it. Now, this may seem a bit strange, but this shop uses imperial measurement. And for those not familiar, there's effectively 2 ways of working in imperial. The first is a simple fraction. It's half an inch, 3/4 of an inch, 7/32 of an inch. But then we also use what's referred to as decimal. Now that is, instead of splitting an inch into fractions, you split that inch into 1,000. And 1,000th of an inch we refer to as a thou. Yes, I know it can mean something subtly different in metric, but we'll stick with English for the moment. And so the 2 systems we'll use is fractional and what I'll call decimal, okay? Now, fractional we use when we're cutting a piece of plate steel for welding, when we're trying to size a rivet. Oh, it's half an inch diameter, it's a 3/4 inch thread. And to measure that, you'll often use nothing more high-tech than a good old-fashioned rule and a pair of these old charmers, which people are going to look at and say, oh my lord, I thought they went out with the ark. No, I still use them. I still like them. Stiff joint calipers. Very old-fashioned, very traditional. They work underwater, aren't affected by coolant. They don't get damaged if you drop them, and they're very simply used. You'll simply close them up slightly, tap like that, or open them like tapping so. And they're actually surprisingly accurate. With a bit of careful measurement, you can get. I've used these partially as a bet, partially as a dare, partially to see if I could. I've used a pair of stiff joint calipers like this to get 5 thou or better tolerances on machine parts. So they're not so completely obsolete as to be overlooked. But the problem with these things is they depend a lot on the skill of the operator. And it's the old joke about touch like a midwife. If you haven't got that touch, then you won't get accurate, repeatable results with these. And so what other measurement systems could we use? Well, we could use a set of modern digital calipers. Wonderful things. Superb if you want to translate from metric to imperial, but they really don't like coolant, and they're not, in my opinion, terribly accurate. So what we fall back on is, again, we won't look at that one for a minute because it's semi-dismantled. We'll look at this one because it's actually in one piece. The micrometer. An instrument that hasn't really changed its basic design and concept since it was invented by James Naismith and Joseph Whitworth. Now, the idea of a micrometer, the way it works is it relies on a very accurate screw thread. If you look down that hole there, we should just be able to see the female screw thread there. And the barrel here, we can just ignore this nut here. This is part of the anti-backlash arrangement. You can see there's a very fine screw thread on the barrel there. And so the way this works is as you wind this thimble here, that's the bit where it says the makers, Slocum of Providence, Rhode Island, as you wind that in, as you engage it with the screw thread, wind it in, that will close up the gap between the anvils, that is this here and this here, very slowly. And if you look on the body of the micrometer itself, you will see there's a linear scale on the barrel. You can actually see it better on this example. It's been taken apart. You can see a linear scale on the barrel, but then you'll also see a series of finer graduations around the rim of the thimble. And as you rotate that thimble, you will see that one by one, those graduations line up with the scale on the barrel. So you will see how that's 20, and then to 0, which is actually 25, just to be entertaining, and then 5. Now, if you look at that, you'll see already that first graduation, the 25 graduation is exposed, but we've now gone on an extra 5 thou. So that, of course, is 30 thou, 35 thou, and 40 thou, 45 thou, and then finally another 50 thou. Now you can get what we would call a tenths micrometer, which has a second vernier scale on the barrel here, where you can actually accurately measure to tenths of a thousandth of an inch. Now, I'll be honest, at that stage you're starting to get into things like surface finish, and you're also starting to get to temperature affecting the accuracy of the measurement. We usually work to thous, might work to half a thou just for a bit of variety, okay? Now, there's the thing with the micrometer is the screw thread here, if that screw thread has a little teeny tiny, maybe a millionth of a thousandth of a tenth of a thou, if there's any error in that screw thread, plus also screw thread has to have a slight clearance in it to work, then that error will be multiplied by every rotation. So it's normal design for micrometers that they only measure a short distance individually. They usually have a range of about an inch. It's pretty much standard, or 25 mil if you're French. Now, so the thing is, if you can only measure an inch range, how do you measure, say, something that's... Well, you obviously can't measure something that's just over an inch, say an inch and an eighth, and something that's 2 inches. You can't measure them with the same micrometer. So what you would have is, you have each micrometer will cover a different range. This one will cover from 0 to 1 inch. That one covers from 0 to 2. Get another one with a bigger frame, 1 to 2. And then another bigger frame, 2 to 3, 3 to 4, and so on. The other style you can find is that these anvils here in the frame can be interchangeable. You can simply put another anvil in, and so you can have a micrometer that with one anvil in will measure from 0 to 1, put a shorter anvil in, it'll measure from 1 to 2. Now, this is another little thing with mics. The 0 to 1 micrometer, it's very easy to set it, that is, to calibrate it, because what you need to know is when it's wound all the way out to 1 inch, which will look like, wait for it, that, okay, that's currently measuring an inch. You need to know that that is actually measuring an inch. Now, the 0 to 1, it's dead easy. All you have to do is wind it all the way closed, and when that anvil there is up against that anvil there, it should say 0.0 on the scale. If it does, bingo. The problem is when you get into the larger ranges, because there's already a gap between the anvils, you can't close them down to do that. So at this stage, you use one of these, known as a setting bar or a standard, okay? Now this is a piece of steel which has been accurately ground and machined to a certain length, and you know that length. There'll be a certificate of calibration provided with it, and so you can use that to set your micrometer. The plastic jacket on it, incidentally, which is where I'm holding it, is so that the heat from your fingers cannot cause that piece of can't be transferred to the steel, and so cause the steel to expand. If I was to hold that piece of bare steel in the palm of my hand for 5 minutes, it'll probably expand by somewhere in the region of 3 to 5 thou. Now, if you're trying to set a micrometer with that, that's not going to work. On the other hand, that plastic sleeve will insulate it from the heat from my fingers, and so hopefully it shouldn't expand at all, okay? So that's how you would measure an external diameter, say a shaft, okay? How do you measure the hole that shaft's going to go into? Well, you use an internal micrometer, of course. Internal micrometer works exactly the same principle, accurate screw thread. There's a couple little differences. This set has a range of 1/2 inch rather than an inch range, and also because you can only measure an inch at a time, this is the interchangeable anvil style. So you have this anvil here will remove, and you can simply replace that anvil with another longer one from the set, and so you would work up. Now this is where it gets interesting, because I said it's only got a range of 1/2 inch. That's where this little doofer comes in. This is a 1/2 inch spacer. So I'll set up normally with the first anvil in, and I really should have done this before I took it to pieces, but never mind, I'm sure we'll rise to the occasion. There we go. With it set up like that, it will measure from 2 to 2.5 inches. If I then put this little spacer in, wait for it, like that, getting better at this, like that, and then finally like that, it will now measure from 2.5 inches to 3 inches. And the same procedure would apply with any of the other rods within the set. You simply put the rod in, it will measure from, I don't know, 5 to 5.5 inches. Put the 1/2 inch spacer in, 5.5 inches to 6 inches, okay? Right, so that's how you measure a bore, sorry, the diameter of a bore. But let's say, just to be awkward, we want to measure the depth of a bore. Well, yes, you guessed it, it's a depth micrometer. Works exactly the same way as all the others. It actually looks remarkably similar. There is a family resemblance. But the difference starts there, because instead of having a frame with 2 anvils, instead you've got a series of rods which insert into the body of the micrometer themselves. Just like your internal micrometer, you have a range of different rods, because again, the micrometer will only measure a certain length. And so you're putting one rod will measure from 0 to 1 inches depth, the next rod from 2 to 3 inches, and so on and so forth. As you can see, you've got the mic there, and then we've got the different rods that slot into it, okay? To fit them, you simply unscrew that cap on the end of the body there, the rod pushes in, screw the cap up again to secure them, okay? And then the last thing I'll talk about is this, and it isn't the micrometer. This is a bore gauge, and I use these an awful lot. I use these when I'm doing a lot of my pin and bush work, and there's one very simple reason for this. Although this instrument does not measure directly, what it does is it gives me a very accurate indication. I use it as a gauge simply. The ends here are telescopic, as you can see. They slide in and out, and this little screw at the end locks them. So if I push that into a bore, open it out, and then lock it, it will get so that those 2 telescopic ends locate in the bore and give me an accurate gauge for the diameter of the bore. What use is that? Well, if I go to a micrometer, I can then measure the bore gauge. Now, this has one major advantage, which is I will then use the same micrometer to measure the pin or rod or whatever that's going into that hole. So as a result, I'm not relying on one micrometer being calibrated to another. No. I'm using the same micrometer all the time. So as a result, I don't need to worry about that micrometer's calibration. I just simply know I'm relating it to itself, and so it should work, okay? And it's why I like bore gauges for a lot of the pin and bush work I do. I use them an awful lot. So anyway, folks, something a bit different. I hope you found it educational, informative. I hope at least some of my viewers have stayed awake long enough. And I hope you went away saying, oh, that's what one of those does. So anyway, folks, I hope you found it interesting, informative as always. Hopefully next week we'll have a few more machine things to point a camera at. As I said, I've only been in one day this week. And so hopefully we'll be back to our usual tricks next week. So anyway, folks, take care, and I'll see you around.